All right, so today we're going to go ahead and look at some additional properties that we're looking at when we're dealing with angles having to do with parallel lines. And what we're going to find is a lot of the things that we found that were true about the angles of parallel lines can also tell us that two lines are in fact parallel. So that's again we're talking about the converse. It is a lot of these are biconditional statements, and you should have seen that on page 1. You noticed a lot of the theorems from the first page in the notes here really are just the converse or the opposite, or not opposite, but yeah, converse of the theorems that we looked at in section 3.2. So going through the first few questions here, if you read through the first section of the book, you would also notice that these particular pieces were already covered in the very last part right after theorem 3.10, but we'll go through them. Show that a pair of blank angles are congruent. If we want to prove that two lines are parallel, one of the ways we can do that is with corresponding angles. If two lines are parallel, then their corresponding angles are congruent, and vice versa. If there are two corresponding angles that are congruent, then the lines that are making up those corresponding angles are in fact also parallel. All right, so then show that a pair of alternate interior angles are congruent is another way that we can show two lines are parallel. We do know that same side interior angles should be supplementary if it's parallel lines. So this would be same side interior angles. And then here it says in a plane show that both lines are blank to a blank line. So that is saying that we're showing that both lines are perpendicular to a third line. That one there, if you look back, is actually theorem 3.9. That one's a little less intuitive than the other ones. And we could also show that both lines are parallel to a third line. These two are more or less, or the fifth one is really just kind of like the transitive property. And then this one here, you can look back into the notes, but this one was theorem 3.10, or 3-10. Now, looking to the next problem here, which segments are parallel? So what I would say with this one is initially, and you can't always kind of guess, but we can start to get a decent idea of which ones are parallel by just looking at the ones that look as though they could be parallel, and we can base part of that off of the angles as well. So if I wanted to take a look here at just AD and just BF. Okay, this one's a little more challenging. It's pretty small. Okay, so something like this. Okay, well then I would be looking at the two angles here, and I can extend these out so that I can see more clearly that we have a transversal here, and kind of covering part of the problem up that I want. Okay, we can see here that AD, okay, and BF bound these angles, and there's the transversal going right through here. So in this case, 36 degrees and 38, the two angles that those are measures of, well, those should be corresponding angles, and if they were congruent, then we would be able to say that BF and AD are parallel, but in fact they are not congruent, so I specifically know that AD is not parallel. It's kind of a symbol I just made up to BF. Right? Now, looking at the other ones that look like they could be parallel, I'm going to move my little stickers here around a little bit, and in this case, just in the interest of space and time, I'm going to go ahead and see if we can just ignore the one angle there for now. Again, if you want to use highlighters, that would be another way we could go about this. In fact, I will go ahead and do that If we highlight this one here and this one here, well, we can see that in fact we're talking about the angle right here and the angle right here. And this angle, we know from the angle addition postulate, we can take 24 and 36 and add those together, and we get that this is 60 degrees. And if we do the same thing here, we're going to find that this angle is also 60 degrees. These are in fact corresponding angles. Okay? If we extend them out here, we can see that this angle should correspond with that one. So in this case, we can say that AC is in fact parallel to BE. And the reason would be because of corresponding angles. Okay? And looking back to our theorem sheet, that would be postulate 10. Okay. All right, and I will leave this second one here to you, but I can tell you it's going to have to do with theorem 3.9. Okay, as you can see, there's perpendicular lines here, so I think it's fairly clear which ones would be good, and you just need to find the value of x that's going to make it work. Right? Moving on to some of our next problems here. If we'd like to find the values of x and y that make j parallel to k and L parallel to t, in this case, they're looking for two different things. So I'm going to go ahead and just focus on the first one first. So we see here that j is supposed to be parallel to k. So we're looking at these two here. So I'm trying to prove that j should be parallel to k. So in fact, in this one, I can see that the two angles I'm going to deal with are made up of lines k and L and j and L. And in fact, line T really doesn't have anything to do with this particular part of the problem. So as usual, I'm going to cover up the part that might confuse me. And then we should be able to tell that 60 degrees and 3x should be, that's right, are corresponding angles. And for this to be parallel, corresponding angles must have or be congruent or have equal measures. So in this case, I know that 60 degrees should equal 3x degrees. Okay, we divide by 3 on both sides and solve and find that for j to be parallel to k, we know that 60 must be equal to 3x, and that happens when x is equal to 20. Now, moving on to the next problem here, I'm looking for y now, and I can see that, and again, some of this is going to take some work, but in this case, I know the 3x probably isn't going to be important for this part of the problem, and I can see that 60 and 2y, as you get more comfortable, you kind of see, oh, those are probably alternate interior. I'm going to go ahead and cover up line k. Okay, and in fact, for this part of the problem as well, we're just supposed to be looking at L and T anyway. I'm going to go ahead and label these over here. All right, so for this part of the problem, I can see that these two are in the interior of my two lines and on alternate sides of the transversal. So these should be alternate interior angles, and if these are parallel, then 60 will be equal to 2y. Okay. Divide by 2 on both sides, and we find that for these two lines to be parallel and 60 to equal 2y, we must have y equal to 30 degrees. Right? Moving on to the next section here. If you notice, I went ahead and used the strategy of color coding them to help me stay nice and organized and keep all of these angles together. Another strategy I would recommend is maybe making a couple copies of the diagram. That way, we're not getting too jumbled because we're going to have a lot of information here. All right, but getting started with these ones, we see that we're supposed to say whether or not we can find two lines that are parallel given that the measure of angle 1 is equal to the measure of angle 4. And in fact, I'm going to go ahead and just write, show that they are congruent. If their measures are equal, then the angles themselves would have to be congruent. Now, take a second, see if you can identify which angles these, or what type of angles these might be. I'm going to go ahead and say, well, I know here that line J isn't going to be terribly important. I'm going to label these lines L and T since I'm going to be covering up the top here. And I know line N isn't also probably going to be important with this, as it doesn't make up either one of these angles, but it's harder for me to cover that up, so I'm going to try to just ignore that for now. Okay, we could also use our pens to go ahead and highlight it. I'll wait to do anything like that for a moment. Right, now we see that 1 and 4, hopefully you figured out that they are corresponding angles. Okay, and since they are equal, we then know that L and T must be parallel. Okay, and that, of course, is going back to postulate 12 or postulate 11, stating that if two lines are cut by a transversal and corresponding angles are congruent, then we know those lines are parallel. Okay, 1 and 4, okay, are the two lines being cut by the transversal, and they are corresponding angles that are congruent, so we know that those two lines must be parallel. All right, moving on to the second one, we have the measure of angle 6 is equal to the measure of angle 4. So I'm going to go ahead and label those ones in blue. Okay. Okay, so in this particular case, I can fairly clearly see that I'm not really going to be dealing with any of the lines that are over here. And in fact, again, in isn't making up any of these, but in's kind of hard to get out of the way. So I'm just going to cover up at least one of them, so I'm dealing with a couple less lines. And I can see here that the measure of angle 4 and the measure of angle 6 are both on the inside, are bounded by J and K. And the other line making them up would be T. So I'm dealing with these two lines and then the transversal T. They're on alternate sides of the transversal and on the inside here. So I know that those are alternate interior angles. And because they are equal, I know from theorem 3.5, okay, that these two angles being equal means that the lines that create them, J and K, must be parallel. Okay. Moving on to the next one here, we have that the measure of angle 2 and the measure of angle 3, okay, so the measure of angle 2 plus the measure of angle 3, so this angle plus this angle here, must equal the measure of angle 5. Now, this one might seem a little bit tricky if we're looking, or just because it has the addition sign in there. But again, if I cover up the line that really has nothing to do with the problem, this particular piece of the problem, like this, okay, oops, okay, then I can pretty clearly see that these two, in fact, are angles that are bound, or at least created, by lines L and T, and then I have a transversal of K, meaning that these two are corresponding angles. Okay. And the fact that they are equal means that the lines that help create them, L and T, must be parallel. And that would be postulate 11 once again. Okay. And I'll do one more and then leave the rest for you, but hopefully you're getting the hang of this. Now, if we move on to number 4, okay, well, number 4 says we're taking that the measure of angle 2 plus the measure of angle 3, so again, I'm looking at this angle here, plus the measure of angle 8. Now, I'm going to put 2 lines for this one, and we'll see why in a second. Again, we want to be careful, because when we put the same number of lines, it means they're congruent, and this one is supposed to be pink. It kind of bled through with the yellow. All right, and it's saying that this one plus this one is supposed to be the measure of angle, or it's supposed to be equal to 180 degrees. Well, as soon as I see 180 degrees, I'm automatically going to start thinking of same-side interior angles, since I know that they are supplementary, right? But looking at these, I can also clearly see that I'm not really working with line T in this particular case. Okay, and I have J and K here. Okay, and I can see that these two angles are on the interior of J and K, and L is going to be the transversal. So I have two same-side interior angles. I know that same-side interior angles, in fact, add up to 180 degrees if J and K are parallel. And since they are stating that this angle here, and again, we're combining this is angle 2 plus 3, but that just makes this big angle, and this one is on the same side interior angle with angle 8. Well, if I know that if they add up to 180 degrees, then J must be parallel to K. It's the only way it works. Okay, and I'll leave the last few for you to try. Okay, again, try using the same strategies that we were using before. Okay, and moving on to the last section here. Given that transversal T cuts lines L and N, and that angle 2 is congruent to angle 1, prove that L is parallel to N. So first, let's go ahead and mark this down on our diagram here, saying that angle 2 is congruent to angle 1. Okay. And now you notice that they put an angle 3 here. Generally, that's going to hopefully tip you off that we're going to be looking at a relationship here. Well, because I know that angle 1, and again, if you notice, I haven't even looked over at my 2-column proof yet, I'm going to go ahead and solve this, make sure I'm good to go, and then we'll go. So I know that angles 1 and 3 are congruent because they are vertical angles. And now I would know that angle 3 and angle 2 are congruent to each other, okay, because they are corresponding, they are corresponding angles, and they're congruent. Well, I know from my theorem, or from postulate 11, that if corresponding angles are congruent, then the lines that make them up are parallel. So I already have my proof. So here they have angle 2 is congruent to angle 1. First statement generally is a given. Now they state, and if you notice they went through the same steps I did, angle 1 is congruent to angle 3. We know that because they are vertical angles. Now they state that angle 2 is congruent to angle 3. Now you might be thinking that this is because of corresponding angles, but we have not proven that L and N are parallel to each other, so we cannot assume that these are congruent based off that. But if you notice, we have this statement up here, and we have that angle 1 is the same thing as angle 3, as angle 2, my mistake. Okay. Angle 2 and angle 1 are congruent to each other. So instead of writing angle 1 here, I can write angle 2. So angle 2 is equal to, or congruent to angle 3. And we just, you guessed it, substituted. So that's the substitution property. Now, based off of the fact that angle 2 is congruent to angle 3, corresponding angles are congruent if and only if those lines are parallel, and we saw that that was in fact postulate 11, and you can look back to it. If you have any questions, please come prepared to ask them in class. Otherwise, that concludes this edition of Mr. Cooley's Video Notes.